Hey everyone, welcome to my 40th stream. Can't believe I'm already at number 40. So, I was just going over some stuff I experimented with. Yeah, so let me see here. Just give me a second. Yeah, David Parrott on Twitter actually wrote to me, and he was suggesting I try something else. He was saying, for the glow blur, can you not render to a smaller texture? Blur, render that to the larger texture and draw the crisp lines on top. So I tried at least the first part, and it didn't actually give me much. I think that's what I have over here, where I tried different things. Where I tried rendering to not exactly half, but you know, some fraction of the viewport, and honestly it didn't really give me much. So but I do think though, as I've been doing a bit of thinking, and I think the solution to making the blur and all that look good is it's going to be in a few parts. So one thing is that right now I'm trying to blur an image that is mostly black, has some white, very thin white lines on there, like literally like 1 pixel thick, right? And so trying to blur that, I'm not getting much of an effect. And so I come back to this thought that I had last stream, which is I need to make my lines thicker. So to do that, I need to convert my lines into quads when I actually draw them. Now doing that will just give me more pixels to blur, right? And also I think it'll just look nicer. Whenever we look at images of you know, like here, I mean, these are much thicker lines than what we're seeing on my emulator. You know, let's say we take this and let's run the emulator here. Oh yeah, I've got the massive blur going on here, but there we go. You know, I've got like these really thin lines. I can also just take this away. Oh yeah, this is actually with that change in effect here. Let me just revert. You know, I'm gonna just stash it. Smaller texture for blur. Just stash that and go back to what we had before. Okay, so here you can see like the very thin lines, you know. I could actually play this game, but anyways, yeah. So you can see like my lines are a lot thinner, just in general, you know. So I think if we make the lines and the dots all thicker to begin with, first of all, it'll approach this, and it'll give me more chance to get something decent out of the blur. And then I will do the kind of redrawing on top. Unfortunately, you know, when I read about like doing blur, so I did read a bit more about blur, or glow I should say, and you know, that is kind of like the recommendation is you draw your scene into a buffer, and then you blur it in both directions. You do like a Gaussian blur horizontally and vertically, and then you take this texture that you have that has the blurred version, and you draw again, you know, kind of thing on top. Or in fact, if you want to do a glow for a specific set of pixels, they kind of say like take the things you want to glow and draw them with a solid color. So only those items that you would like to have, let's say, a glowing outline around it, right? And think like 3D geometry or something like that. So a 3D object in the world, and you want to have like a halo, a little glow around it. So you draw that thing flat shaded with the color of the glow, and then you blur it in both directions, which should spread it out. and then you draw your scene, you alpha blend this thing on top, the glow effect, and then you draw your objects on top. So there's a similarity there. And the thing with my emulator that makes it a bit more complex is that I have this this feedback every frame, because what I do is I draw into a buffer all my lines, then I take those and I darken those into a second texture. So this second texture contains the lines drawn darkened, and then I actually use that texture next frame as my source texture onto which I draw more lines. And the whole idea is to kind of simulate what a CRT is doing, which is we're drawing lines, and those lines will slowly darken back. You know, the phosphors will go to black over time, right? What that means though is I don't have like a fresh full scene of all lines I can draw this frame. I need to, you know, keep the lines drawn from previous frames in this texture. Now there are different ways I could handle this. I was thinking about it, like if I did want to be able to start from scratch and draw all the lines, what I could do is I could collect, like in a buffer, all lines and let's say have a timer on the lines, and then lines could expire, you know? And if I did that, then I could always start from scratch and just draw the lines with a brightness that's proportional to how much time is left. You know what I mean? Or I could, you know, create lines and instead of, you know, have a timer, instead of having a timer in there, what I mean is have lines with a brightness value and then have that brightness value decay, and as soon as the brightness is at 0, remove those lines from my buffer. Now I could do that, and maybe I will at some point. The only thing is if I do that, I have to deal with the persistence of this buffer over time. So that's one thing. I need to also deal with the fact that I need to do it efficiently, right? So I don't want to be growing a buffer. I need to kind of remove, but I don't want it to be like, you know, thrashing my memory and moving things everywhere. So if I use a vector and I remove things, I need to kind of cycle through and reuse the ones that have been set to 0. So it's a little bit messy in terms of like managing the container itself. So, you know, things like that, right? So I could do it, and maybe I will eventually. But for now, I think I can get away with what I'm doing. I kind of like what I'm doing. It's kind of like a light version. Because I kind of like the idea of simulating this CRT and using my pixel shader to darken the lines. One disadvantage also to the current method I'm using though is if I wanted to port this to another platform that doesn't support SDL, right now I'm putting the onus, or not SDL, I should say OpenGL, right? I'm putting the onus on the rendering implementation to take care of the whole concept of line decay. Whereas if I do what I was saying before and kind of push it back into the emulator and have this like buffer of lines that has this decaying brightness there, then that actually simplifies the job of the rendering part, which would make it easier to port and put less responsibility on the rendering. So that is, I guess, another pro for going in that direction. So that's something I was thinking about as well. You know, so let me. Since I've been talking, let me just add this into my to-do list as a potential to-do. So I'll say emulator can maintain a vector of lines that contain a brightness value persist a vector of lines that contain a brightness value that decays to 0 over time, at which point the line can be replaced. This moves the decaying lines into the emulator and outside of the rendering. surface render. So this would also simplify the rendering, right? Because I could just say, I've got a bunch of lines, I just draw the lines. And then coming back to the whole blur situation, right? I can now draw the lines, blur, and then draw the lines again. That's something I can't do right now. I can't just draw the lines again on top of the blurred value because I will not get the lines from previous frames. So what I need to do now is I need to actually sample the texture of all lines, including the decayed ones, and basically right now what I'm going to do is going to say if the pixel is not black, then take that pixel when I'm applying it on top of the blurred textures. That's what I'm going to do right now. But like I said, it's not as simple as what I could do if I had this vector. So I'm gonna roll with it for now and see how that goes. And if I see that it sucks, we'll go for this kind of solution. All right. So first things first, let's make thicker lines. So right now, the part where I take this vector of lines that's being passed in here and kind of convert it, I have this whole concept of separating them into points and lines, because a line where the start and end point are the same or nearly the same just don't show up when we try and draw them as a line in OpenGL. So I have to split them out into points and lines. So I have this code here, right? Now what I'm thinking of doing is, I'm going to turn my line vertex array here, rather than draw these with GL lines, which is what I do here. We're going to want to draw these as GL triangles. Okay. Oops. Now to draw these as GL triangles, I'm going to want to probably do that for points as well. So let's just start with the lines and we'll handle points afterwards. Which actually means I won't need 2 containers if I just do this, because I'll have quads for everything. Yeah, so that's pretty good. Okay. So now instead of adding 2 points, we're going to want to add 6 points per line, right? And the way we'll do that is, okay, so we're going to create a GLN vec2, and we'll say, give me a vector from 0 to 1, which would be equal to, say, P1 minus P0. And in fact, let's make that, I think it's GLM normalized. GLM normalize, oops, normalize. Okay, so let's get the vector from P0 to P1. Now we take that vector and we create a normal n, which should basically be equal to v01 y negative, let's say. Does that have to be negative? I guess it doesn't have to be. We just flip the 2, because we're working in 2D and we know that it's really a simple case, right? Alright, so we swap the 2, so we get the normal. And now we do the 4 points of our quad. Let's compute those. Those are like A, B, C, D or something like that. So we'll say P0 plus N C, D. P0 plus N. B will be P0, let's say minus N. Then C will be P1 minus N. And then P0 like this. And then we will do Is there a way to push back multiple points? insert, apparently. Position initializer list. Okay, so that means that we should be able to do at the end with an initializer list, and we can put our points here. So like A, B, C. There's one triangle, and C, D, A, I suppose. This should be insert. No? Okay. So this should in theory do the trick. So let's just see what this looks like. Oh, looks like it actually worked. I'm gonna disable the glow. Oh, no. Oh, wait. I think I messed up the order of my triangle here. A, B, C. Really? Oh. Copy paste error. Okay, there we go. Okay, it's a bit thick. But it's thick, but you see we are getting a nice blur effect. Okay, so we can play with that thickness. Is that right? Yeah, this is right. It's just too thick. Let me try and make this thinner. Line width. You know what? We'll make it a line width. And what is it gonna set on? Okay, so say we have a line width, so we can multiply that here. Actually, it's not letting me keep it. It's okay. It needs to be static. There's something, no, I think I got something wrong here because it's not quite rendering right here. Let me see. Oh, is that because of the points? No. I'm wondering if it's like a winding issue. Just turn that off. Strange. Like, it's strange how those lines don't show up. Did I do something wrong here? Okay, let me just think about this for a second. I think it is my winding. Just draw this. And that works. Okay, so this is P0, P1. So P0, get our normal. A, B, C, and D. I'm doing A, B, C. So like this, like this, like this. And then I did C, D, A. Oh no, that should work. The default is front face is counterclockwise. That's what I'm doing. You just try and disable it just in case it's related to that. GL disable, GL cull face. Let's try that. No, it's still happening, so it's not that. You know what, let me try taking a capture and see what we get. How do I... Anyway, it's interesting. We can see the lines at the top there. Don't know how to move. How to pan. Damn it. Okay, so these are the lines, and then these are the dots. And if I could just get in here, I can't even... Anyway, I can see it, right? There is a super thin line for some reason. Camera speed, matrix, orthographic. Arc. Why would it do that? Why would it? Oh, okay. I did need to flip the Y. All right. Yeah. Makes sense. Okay, cool. So now we have the ability to play with a proper line width. And it actually looks right. See, this looks right now. Now the ship looks thick. You know, this is probably too thick, right? But at least now, you know, if we take this and we do our blur on it, then we're gonna get this nice kind of halo effect. And if we redraw this on top of it, it should look nicer. So, you know, maybe what I'll have to do is draw the thick lines to get the blur and then draw the thin lines on top of that. We'll see. But if I can just get away with drawing the lines in one way. Oh, actually, I can't do it really both ways. That means maintaining two buffers. So let's hope this works. No, I guess I could do it. I could do like the thin line pass and the thicker line pass for the blur, but to do that comes back to the idea of just maintaining this one list of all lines to draw. Then I'd really have that kind of flexibility. So I might have to go that direction. Okay, so let's say we have this. Oh, and let's actually take care of our dots as well. So for the dots, what we'll do instead is we'll also make a quad, but we'll just be somewhat similar. It'll be a one where we'll take P0 back to, we'll do offset will be equal to I'm not sure. Let's see. Take P0 and we'll add, I'm wondering if I should add 4 points in the corners or 4 points up, down, left, and right. Make kind of like a point that's actually, yeah, I guess I should make it square. That'll make more sense. To be honest, it should be more circular, but anyways. Yeah, actually technically line width here should be divided by 2 to really be a line width, you know? So I should do like a half line width here. P0, this should be P0 actually, minus this, or plus this negative, okay, say minus that. And then we'll do P0 plus and P0 minus this. Now, doing this, does this work? I'm adding 4 points. No, I gotta add, no, this doesn't work. I need to add 6 again. Okay. And technically, we can just add them actually into the line VA and leave point VA empty for now. So let's see how this looks. Oops. Let me just disable my blur for a second because it keeps getting in the way. That was glow, yeah. Okay, well that definitely makes our dots brighter. I think 0.5 is probably going to be the sweet spot here. We'll see. Maybe 1. 1 it looks ugly for the main thing, but maybe it'll be good for glow. So, if I'm going to do this, I can't do my glow back into the curve render textured 0 because we don't want to, we need to keep the original lines that were drawn in here and then blend So I'm going to need another glow texture basically. Oh, we just grew like 1 and 2 maybe. Okay, so here we're going to go to glow texture 2. Yeah, I'll be right back. Okay. I am back. So let's see. I keep thinking more and more that I need to do this thing where I manage all the lines with the brightness. Because I really think I'm going to need to separate the thickness of the line for blur versus the ones for non-blur. And it's also, it's just going to be way easier to just draw the lines on top of the blurred version if I could just redraw, rather than do this kind of mixing of textures again. Let me see how I would do it. So right now I have this thing with display and I'm calling draw lines. And then that's the thing that every frame does the transforming, does the taking those lines and then doing this transformation here. So this could be a place where I could store the lines, but then that's very specific to GL render, and I would like to kind of lift this into the emulator, which means changing a little bit what I'm doing. Alright, actually I'll start with managing the lines here. I'll see about lifting them. Oh yeah, I forgot about this hack where I'm storing in the VIA chip. These are all public right now, just so I could access this lines thing. I'm wondering if this here I should do it. Should the VIA maintain the lifetime of these lines? It doesn't feel right. maybe it's a bit more clear. Get and clear current frame lines. And in main, we don't always want to clear them, right? Then maybe it does make sense for the via to maintain all lines. Does it? Update it. I don't know. Okay, let's make this a bit less weird. Alright, so I'm going to add brightness to my line, which is a bit weird. But this is not a geometric line, it's really a Vectrex, line, so to speak. So okay, so then if we do that, probably this stuff won't build because let me see how I construct lines. Oh, okay, good. It builds. So now what? I'm thinking is maybe storing these in the display. No, not yet. Let's first start with in here. Okay. We'll just for now add them to the back of all lines. It's not going to be the most efficient, and I'll worry about that after. Do something like go. So brightness. I think it's current plus target minus current times ratio. Say 0.2 and target. Yeah. Where are my rates again? I'm going to need to use iterator so that I can actually remove values here. Instead of calling it update lines, we'll say how about darken lines? And I will pass it actually. We'll pass it the frame time and we'll pass it the lines. Now we've darkened them, and I need this logic here. create a line vertex array. Pass in the lines, and what we want to do is we want to actually create this vertex array. So we'll do like this. Return the result here. Okay, getting there. Lots of changes. Okay, so this builds. And now that I'm doing this, I need to totally change the way I'm drawing lines. So let's see if we can, how can we test this to make sure it works? Without like, so let's see here. Okay, this is gonna be a bit different. So I'm not gonna need the darken texture pass anymore, since we're doing it ourselves. I am gonna have to take into account the brightness though. Well, yeah. I guess not right away. For now we could just draw them and then the lines will just disappear, which is okay to start, and then we'll take into account the brightness and pass it in. That's true that I need to pass in the brightness. Yeah, how am I gonna do that? I guess I'm gonna have to pass it in as a buffer. This time we do want to clear. So we draw our triangles. Okay, let's skip the glow for now. So we're drawing to render texture 0 in here. We are. And here we render that here. So this might work. Wow, that is some bad frame rate. Oh shit. I'm just taking a look. I'm taking a look at the frame rate with all my vector manipulation because it's pretty obvious to me that that's where my speed up, speed downs. Yeah. Maybe 70. Okay, so it's really this darken lines pass here that's killing it. And it's because of the way this works, right? If I erase lines, it's got to shift everything. This is just terrible. So what we can do here, I'm just thinking about what I can do here to make this really efficient. So let me try something. Advance, where and offset. Can I swap through iterators? I think so, right? Iter swap. That's not what I meant. That's what I meant. Okay, so let's see if this actually works. I'm swapping. Okay, that's a much better frame rate. Okay, so I think this is actually working. Yeah, so this looks crazy, right? But it's actually what I expected because I'm not actually using the brightness values right now. So I'm just drawing everything at full brightness until it disappears. So that's what we're supposed to see. Shit, I can't believe this is working. Wow. So just to talk about what I just did in darken lines, because I didn't talk about it. So by iterating through this array and removing arbitrary, like erasing arbitrary values in the middle, this is basically like a worst case scenario for dealing when you're working with vector. Now I want to work with vector because, you know, it's the fastest to iterate through, and it's cache friendly and all that. But for arbitrary erasing elements in the middle, it's terrible. So this trick here is to basically say, all right, we have some, let's say, massive vector of lines, and then we're going through it, and let's say some element in the middle needs to be removed. What we do is we temporarily swap it with the last valid element, right? And actually, see, now that I'm talking about it, I'm wondering if I'm doing the right thing here. After swapping it, I kind of need to still process the next one. Yeah, so, okay, anyways, just to finish, I swap it with the last element, and I have this iterator that's pointing at the last valid element, and I move that back one afterwards so that I can swap the next one that needs to be removed. And then at the very end, I take this last valid iterator, which is now pointing at the last valid one. I move it, advance it one more, which I guess now points to the first invalid, and then I erase from the first invalid to the end. Now this erase here will just be erasing a whole bunch at the very end. So this is actually going to be really cheap because there's going to be no shifting that it has to do. And furthermore, it won't actually reclaim the memory. So this is a vector that's just going to keep growing, and it'll achieve some kind of capacity for, you know, the most amount of lines I've ever needed at one time, and it'll just kind of remain that way, just one big block of memory. And then within there will be changing size, but it'll be this one big fat block of memory at some point. So that's really good. It'll just take a few frames to get there, and then once we're there, it'll stay that way. So I could probably, you know, to avoid that, I could also set the initial capacity when we create it, but anyway, it's no big deal. But I just realized now that when I swap, I'm taking the last valid element and I'm swapping it, but then I'm advancing my iterator in that case, which we don't want to do. We need to process this valid element right away. Otherwise we'll skip them. So it'll be more like we do a plus plus in the else branch here. That's it. We swap or we do plus plus. Let me see how that looks. Now this is complicated. I would love to do this in a function, but it's not. I don't think it's easy for me to. Whoops. See, now I ran into a case where it's not working. Let me just work through this for a second. I guess there's a point where I shouldn't swap if the last valid iterator is mine. That's probably what I'm getting right now. Is we may have an overlapping case here. Let me see. Not gonna show it to me because I'm not in debug. But anyway, that would make sense. Basically, if I reach a point where my current iterator, let's see, could this happen? Yeah, exactly. I move my current iterator and I'm on the last valid one, and then I see it's invalid, right? And at that point, I want to swap it with itself, which I suppose that's not valid. I suppose. So let's see. I don't know. Maybe it's okay, but oh, I'm stuck in an infinite loop now. All right. Okay, no, I think this should be done a bit differently. Okay, so let me see. We initialize end iterator to the real end, so it points one past the last valid element. Now, if we need to remove, what we do is we move end iter one back, and we swap iter with end iter. So now it still points one past the valid end. And then when we get to the end, now iterator will, when iterator reaches that, we stop, which makes sense. And then after that, we have to delete from the so-called end iter here. Yeah, this is actually cleaner. Hopefully this will work. Okay, this looks like it's working. Okay, let's say that works. It's actually a lot cleaner doing it this way. Yeah, so like I was saying, I would love to like find a way to do this with a proper like you know, like extract this kind of logic out, but I don't think I can easily do that because of the fact that I need to keep state, you know, to get this done correctly. Okay, so now I need to figure out a way to pass that those brightness values for my lines. So I'm just thinking, you know, I have these 6 points, right? 2 triangles per line that I'm sending in. And for all 6, I would need this one brightness value. But I suppose I don't really have any much choice here in terms of like sending the same value for each vertex. And then they'll be like needlessly interpolated, but that's okay. And then I just, you know, effectively it's like the color, you know? But I don't really, I just need like a single float value, kind of like a grayscale color. Yeah. Like here. What are my options here? I would send a separate buffer, I guess. Actually, let me just take a look at something. Right. Oh, actually, I don't have those brightness values right now, do I? Honestly, I don't really need that. Okay, so I have G all lines here, so I could do this. So for the actually, You know what? Okay, I need to change this up. Basically, line VA has to be beefed up here. This is what we're gonna do. And it's interesting actually because we could use the brightness value for each point here. Oh no, we only have one brightness value for the line anyway. I keep doing this wrong. What's the problem here? Oh yeah. Okay. So that's correct here. We want to do the same thing down there. Alright, so now we actually have a proper vector of vertex data. So I'm going to need an offset into this buffer now. believe this size is not right. Or is it? Let's get this wrong. Type 2 floats, not normalized. I think it's the stride that I need to set. Yeah, because here it separates them all. Specifies the byte offset between consecutive generic vertex attributes.
Okay. So basically it's going to be
All right. Three floats for position, 3/4 for normal, 3 for vertex color. If I recall, I can do it this way. Okay, one float, and then here the offset will be for brightness. See if this makes sense. Okay, so we load up the entire buffer, all the vertex data here. We enable attributes 0 and 1. We bind our VBO. Again, no, don't need that. Then we do our, this is for the vertices. For brightness, and now we draw everything. So now, and this is for yeah, you know what, we don't need, I guess it's okay. Vertex array. So it just compiles. Right. This is the function I was replacing, so that's why I don't want this anymore. Okay, so this builds. Now I need to go and modify my shader to take the second buffer of floats that will be interpolated for brightness values. Okay. Draw vectors. Draw vectors. Call this vertex brightness. And we just pass it through, I suppose. So assuming this works, we'll be binding our vertex brightness in location 1. Just write it here, it'll end up in the fragment shader, and we just use it to color, right? Holy crap, it actually is sort of working. Try to figure out why this behaves so differently. Okay, that's better. I needed to brighten my lines at the end so that I think. No, that's not much better actually. No. Just give me a second. I'm gonna get some more water. So yeah, no, I'm not quite sure what's going on here. I'm not like super happy with this result. It seems not quite correct. Like I had it at 3. At 3 it doesn't seem to be doing the right thing. Or is it? Maybe it is doing the right thing. Man, my frame rate's really tanked though. I'm a bit worried about the part of detecting when it's time to remove them. See, the nice thing about what I was doing before, where I was just darkening all the fragments, was that I didn't really care like about this kind of threshold. It would eventually get dark enough, and it didn't matter, you know, really. But here, it matters. It's kind of like I'm doing this continuous approach towards 0, and then at one point, the line disappears, and I think there's some kind of like sweet spot that I have to hit. Like here, this like looks decent, you know, but my frame rate's really bad. And now, like, if I reduce this, my frame rate is immediately affected because this determines how long lines last. Let me try something. Just want to see. Okay, I think my real slowdown is coming right here. All right. No, not much better. So I thought maybe if I have this global here, eventually the size of it will stabilize the capacity, and then we would just be replacing. But it's just the very fact that we are creating these over and over from the all lines array. It's quite expensive. Maybe I can not do that. Yeah, like why am I bothering to transfer this at all? Oh, right, because of the... No, of course. I need to create this because this is actually... Sorry, my vertex array is actually the ones with the triangles for the quads. That's why I need to do this. Right, of course. Let's try our performance profiler. Let's take a look at what's happening. Okay, so let's see. Maybe I could just pre-allocate this buffer instead of doing this insert range. That would actually be a nice optimization. Let's see. We're going to initialize this with a size that's going to be basically proportional to the number of lines we have. And let's multiply it by, it's going to be about 6 points per line. And plus a float. But no, sorry, it's going to be 6. Yeah, 6. Let's just try that. It's effectively a reserve that we're doing. Okay, not much faster. Let me see here. Is this really the right function though? This actually initializes. Okay, well, it's a bit better, but still not great. Let's profile again. It's still slow. Reallocate exactly. Well, 50% of my time is being spent in those two functions. Create line vertex array, which is 30%, and my darken line is 22.9. Hey, Benjamin. Benjamin says, doesn't that initializer list allocate memory each time? So I reserve enough space here, so this should just be a copy. And that's actually what it looks like it's doing. In this insert range, it's just doing a U copy. I mean, I guess I could avoid making the initializer list and just do an in place back. Yeah, it's because it's a lot of data, right? It's a lot of lines, and I'm now basically what I've changed is I used to only have as many lines as whatever delta time for the frame would like I would update a frame for a certain amount of frame time, and I would only get as many lines as were generated during that time. But now I'm keeping in memory all lines that have not expired yet. So, and you know, the expiration means the brightness goes down to some, you know, threshold near 0. So basically I can have a lot of lines in memory. You're making me think that maybe what I need to know here is just how many lines am I keeping around. In fact, we can get a pretty good feel for that. Let's just run, and then we'll break at some point here. Yeah, 95,000 lines. And I have a good idea of what's going on here. Yeah, look at these really small values that are just staying in there. That's my problem. But if I remove them too quickly, we end up, I think, seeing lines that disappear too fast. Now I have 172,000. So my frame rate is better. Really curious. Maybe I'll put a slider on this just to see how it behaves when I play around with that factor. Maybe there's something else going on here. I gotta think about this a bit. Feels like There's some weird artifacting that's going on here. I think I know what it is. I think what I'm doing doesn't really work because yeah, okay, I'm starting to get an idea because I'm looking here, okay, like if we look, say I grab try that again. No, not paint. Paint.net. Okay, I don't think this solution is gonna work. So you see how there's like different, like let's say one of these lines, the brightness levels are kind of like not quite right, you know. There's like some that's, I would have expected, let's say, all these lines to be around the same brightness level, right? But they're not. Like you can really see it over here. And I think what's happening is that when I was using the pixel shader, like the fragment shader to darken, I was doing on a per pixel level, right? Which means each pixel was being treated separately. And it's like as if I had a brightness value per pixel, effectively, which was the color of the pixel in the buffer to begin with. And now what's happening is I have a brightness for some segment of a line. And so depending on my frame, like my frame time, I will generate, let's say, a fragment of a line with a certain brightness. And then the next frame time, I'll generate another fragment, which could be of a different length with its own brightness set to, let's say, 1, but the one before it had some time to decrease in brightness. And so we get these differing brightnesses per segments of lines rather than on a per pixel level. Does that make sense though? I mean, I guess we would get the same effect writing into, because I'd be writing parts of those pixels into the texture. I'm gonna try a linear darkening here. There's something not right here. Is this the thickness thing? Let me try one more time.